Hey y'all, this is the test 2 review for pre-cal. Okay, first you're going to start out by whipping through this unit circle, filling it out. So we're still going to do the same degrees that we did on the last test of 30, 45, 60, 90. And then don't forget we do the pies. And if you forgot how to do the pies, you do 30 times pi over 180, but really you just reduce the 30 and the 180, or in your calculator put 30 divided by 180, math enter, and you should get like 1 over 6. So we're just going to change that to a pi and put 1 pi over 6. Okay, and then you're going to go around and fill out all the other pies. So I need all the degrees filled out for your test, all the pies filled out for your test. Don't forget the points on the axis, like the x-axis is 1, 0, and negative 1, 0. The y-axis is going up, so the x stays 0 and the y is 1, and then down below we have 0, negative 1. Okay, the last thing is, as you're filling this unit circle out, remember that whatever you trace with the x should have the same denominator. So, this x that I traced, all of its points are going to have the same numbers. So, this 30 degrees, any angle from that x is going to have the point square root of 3 over 2 comma 1/2, and here it's positive. And then over here on the left, we're still going to have the same numbers, square root of 3 over 2, 1/2, square root of 3 over 2, 1/2, square root of 3 over 2, 1/2. The only difference is what the symbols are. So in this top right quadrant, all the symbols are positive, positive. So we keep those x's and y's positive. Over here on this top left, the x's are negative and the y's are positive. So that square root of 3 over 2 should be negative. Down below, in the bottom left, we got negative, negative. So both of those x's and y's should be negative. And then in the bottom right, we have plus negative. So our x's is positive and our y is negative. Okay, so I'm not going to go through how to recreate this whole thing. You can either do it by hand using your calculator and conversion, or maybe you memorized it. It doesn't matter. You just have to know it. Okay, so let's look at step 2. It says question 2, write the center, radius, domain, range, and graph. Oh my goodness. Okay, so this looks like the equation, standard equation for a circle. That looks like parentheses x minus h squared plus parentheses y minus k squared equals r squared. Yeah. Okay, so now let's figure out what my hk is. That's my center. And my radius is r. Okay, so for my center, if you notice the formula says x minus h squared, but then when you go to put it in the center as an xy point, the symbol changes. Same thing for this y. So you have to use opposite signs of what's in the parentheses. So our center is going to be, let's see, opposite signs of what's in the parentheses. Opposite of this negative 3 is positive 3. Opposite of this positive 1 is negative 1. Hey, that's my center. Let's go ahead and graph it. It's the same thing as xy. So to the right 3. Oh, I shouldn't have drawn a dot. Oh no. To the right 3 and then down 1. I should not have drawn a dot. Okay, and then let's find our radius. Okay, so we're going to go to the right 3, 1, 2, 3, down 1. There we go. Okay, now let's find our radius. Our radius is not 9. That's our radius squared. So that 9 is r squared. So let's put a square root on it. Hey. And then the square root of 9 is 3. Okay, so I graphed the point wrong the first time. My bad. Okay, but here we go to the right 3, down 1 to get that center. Then from there, we're going to go up 3, around 3, left 3, right, every kind of 3, every direction we can go. So go up 3. And I'm going to go ahead and write down what y value that landed at. It looked like it landed at 2. Okay, now back from that green center, I'm going to go 3 down. And draw a dot. And let me go ahead and label that y value. 1, 2, 3, 4. It looks like -4. Okay, now let's do the x values. From that center, we're going to go to the right 3 and draw a dot. Hey, what's the x value there? How far right is that thing going? It's going 1, 2, 3, 4, 5, 6. Okay. And that's a little tick mark. It looks bad. And then from that center, we're going 3 to the left. 1, 2, 3. Oh, look, and we land right on that axis. And that x value is 0 because it's right in the middle. So let's draw our circle. It looks kind of weird. Yeah. Now let's find our domain. Our domain is the x's. Well, we said that the very left side of this circle has an x value of 0 because it's right up on that axis. The farthest right x value is this 6 with the weird tick mark. Brackets because it's closed holes. Range is the y's. So right now I just did the x's, and you have to do them smallest to biggest. Now I'm going to do the range, and that's the y's. Smallest to biggest. So my smallest y is this -4, comma, my highest y is this 2, brackets. And on the test, it's not going to be parentheses, it's still going to be brackets, so don't freak out. Okay, let's keep going. Number 3, it gives a disgusting point, but it says it's on the unit circle. Alert, alert, hot dog, hot dog. Yeah. Okay, since it's on the unit circle, that means that the point xy is now cosine sine. Specifically, cosine theta and sine theta. Okay, so I would probably write that down on your tricks. Okay, let's see here. So, I think we usually start with sine and cosine. So, sine is the y value. So, that's the second nasty number. -2 square root 6 over 5. Okay, then cosine is the x value. So, that's that -1 over 5. Okay, good. So we got 2 of them for sure. Huzzah. Okay, let's go ahead and find the reciprocals. So let's see. The reciprocal of sine is CSC. So CSC of theta is sine upside down. So let's see what we got. That would be 5 on top. On bottom, 2 square root 6. There's a negative floating around somewhere. So I took the sine and I flipped it upside down because cosecant is the reciprocal of sine. Okay, then we're going to multiply by square root 6, square root 6, and on the top we get 5 square root 6 all squished together. On the bottom we get -2 multiply dot square root 6 times square root 6. That's 36, or just house times the same house is no house. So just put a 6 on the bottom. Okay, and then let's kind of do the multiplication. So 5 square root 6 on top, all over 12. And we don't care whether you put the negative with the 12 on the bottom, on the top with the 5, or out to the side. It doesn't really matter. So what was this? Oh, this was cosecant. You don't have to rewrite that CSC. I was just doing it. All right, now let's do the upside down of cosine. What's the upside down of cosine? Secant. Or it's the reciprocal of cosine. So let's see here. If I take this cosine and I flip it upside down, that just divides out to be a big fat number. So -5 is our secant theta. Yeah, that was kind of pretty. Okay, let's see. So we're supposed to have 6 answers. I have 1, 2, 3, 4. Now we need to come up with our tangent and our cotangent. Okay, for tangent, there's a couple of different ways we could think about this. We could think about it as y over x, or sine over cosine, or if we accidentally drew a triangle, we could have said opposite over adjacent. Either way. Okay, so tangent. I think I'm going to use this y over x thing because it told me that this point is on the circle. So I already have my y and my x. So let me put the part of the fraction with the 6 on top and then -1 over 5 on bottom. So these numbers came from the very tip top of the problem when they said x comma y. And that's cosine sine because it's on the circle. Okay, now what happens? 5's cancel. Goodbye. The negatives cancel. Goodbye. We get 2 square root 6 over 1. Okay, and then we just kind of grow up a little bit, and hey, that's our tangent. You don't have to rewrite tangent theta on the top. I was just doing it for us. Okay, lastly, let's find cotangent theta. There's a couple of different ways we could think of cotangent. We could think of it as its tangent upside down. We could think of it as x over y because it's the reciprocal of this fraction. We could think of it as cosine over sine. I don't care. Whichever one you like. I probably would have just stopped at tangent flipped upside down because that's the easiest thing for me to remember. Okay, so let's take our tangent and flip it upside down. Okay, which one should we do? This super big fraction on fraction? Or should we flip this 2 square root 6 with the 1? Let's flip that. Okay, so we're going to have 1 over 2 square root 6. Okay, then you can't have the square root. On the top, they get squished, and also we drop the 1 because we're grown-ups. On the bottom, we have a 2 multiply dot, house times house, no house, 12. Yeah, so on the bottom, we get square root of 6 all over the 2, and then that was already there. Then the square root times square root just makes 6, and then that makes 12. Okay, and this is our cotangent. And you might be thinking, ooh, maybe I could reduce that 6 and 12. Nah, bro, you can't. That 6 is in a house. It's protected. You can't just go into somebody's house. Okay, let's look at number 4. It says evaluate each from the unit circle. Okay, well, we need to know some stuff. We need to know that sine on the circle is y, cosine is x, and I'm just putting this same stuff that we wrote on number 3. I'm just writing it a different way. You don't have to do that. Okay, and then let's see here. CSC is sine upside down, and you probably already have this written down somewhere. Secant is cosine upside down. And then tangent is y over x, and cotangent is tan upside down. Okay, so if you don't have this written or something like this written, on your cheat sheet, make sure you go back and do it. Okay, so first let's look at 3 pi over 2. 3 pi over 2 is right here at 270. Yeah. Okay. And secant is cosine upside down. So we're going to be looking for cosine upside down of 3 pi over 2. So let's see here. At 3 pi over 2, the cosine is your x, and that's 0. Okay? Well, 0 upside down, let's remember this. I put a pretend 1 on the bottom. Ooh. Okay? And when I flip it upside down, you get 1 over 0. And that's undefined because you're not allowed to have a 0 on the bottom of a fraction. So let's go over that again. First, we found 3 pi over 2. It's at 270 degrees. Then we saw that secant was the upside down of cosine. So we plucked the x value from that 3 pi over 2, and the x value is 0. But we have to flip it upside down. So I brought in my good friend 1 that we can use for any denominator of a fraction, and when I flipped that 0 and 1, I got undefined. Okay, again, let's see cosine negative pi. Okay, well, first off, on the circle, pi is up and around all the way to 180. Okay, so negative pi starts at the same place, only it goes down and around. So pi and negative pi land at the same spot. They both land at pi. Okay, so cosine negative pi means you start on the positive x-axis and you go down and around pi radians, which is like 180 degrees. Okay, so it says cosine. Cosine is the x. X at pi is, here's my pi, x is negative 1. Bam. Okay, third sucker. This one gets us confused because we see that 0 and we think that that 0 are the zeros from these points. Okay, but the 0 on part C is not the 0 from the points. It's this 0. 0 degrees, 360, 2 pi. That's the 0. That is what this 0 is describing. So this is describing 0 pi or 0 degrees. Or I think it's the same thing as 2 pi. So when it says 0, since it does not have a little degree symbol in the air, then it means that has a pi on it. And 0 pi is like saying 0, just 0, as in your angle is 0. So we're going to look at 0 degrees or 0 pi or 2 pi, and we're going to find the y value because sine is the y value. So at 0 or 360 or 2 pi or 0 pi, whatever, the y value is 0. This is where it gets kind of confusing because there's zeros everywhere and they mean different things. Okay, let's look at part D. Part D says cosecant negative pi. Well, we already figured out where negative pi is. Pi is up and around, so negative pi is down and around. But we still land right here at pi. Okay, so cosecant is sine upside down. So let's go to pi, find the sine, that's the 0, and 0 upside down is undefined. Okay, keep going. Tangent 3 pi over 2. tangent is y over x. The y value is -1. The x is 0. And oh, that's undefined, because we can't have a 0 on the bottom. Okay, cotangent. That is tangent upside down. Okay, well, you might be asking, how do I flip undefined upside down? Because these are the same angles, so how do I flip undefined upside down? Okay, well, something you might want to write on your test is that 0 upside down is undefined. Whereas undefined, if you take the reciprocal of that, it's 0. Yay. Okay, let's go back to that f. We were on tangent, and if I just say x over y, then the x value at 3 pi over 2 is still this 0. It's just on a different piece of the fraction. The y value is -1. And then 0 divided by -1 is 0. Alright, let's keep going. Next one says 4 pi over 3. Oh, goodness. And secant. Well, secant is cosine flipped upside down. So let's go to 4 pi over 3. I think it's right here at 240. And we are doing secant. So cosine upside down. We need cosine is -1 over 2. But when I flip it up upside down, you get -2. So 4 pi over 3 has an x value of -1 over 2. I knew to find the x value because it was cosine. I knew it was cosine because it was secant. Okay, and when you flip -1 over 2 upside down, it just becomes a big fat whole number. Okay, same angle. Now we look at CSC. Well, CSC is sine upside down. Sine is the y value. Let's find it. The y value at 4 pi over 3, it is negative square root of 3 over 2. Okay, let's see. If I flip that bad boy upside down, the 2 goes on top, the negative square root on bottom, multiply by that square root. On the top, we get 2 square root 3. On the bottom, we get -3. And hey, that represents cosecant of 4 pi over 3. And you can put the negative on the bottom, or the top, or out to the side. And all those questions that we just answered depend on whether you filled out this circle correctly. So if you don't fill out the circle correctly, these questions are going to be difficult, because you're not going to know exactly where to look. Okay, let's look at number 5. It says, given the following of a right triangle, okay, find the other 4 trig functions, no decimals, and reduce or rationalize if needed. Okay, so we're on a triangle. When we were on a circle, xy was cosine sine. Now that we're on a triangle, we're going to go back to SOHCAHTOA. Okay, so sine is so. The square root 5 is the opposite. 3 is the hypotenuse. Okay, and remember, we need to draw these triangles like they came from the bow tie. That way we'll never mess ourselves up. So, if you think of a bow tie thing that people wear around their necks, or that pasta that you eat, the theta is always the angle closest to the center of the circle of 0, 0. Okay, so theta is at the bottom left. We labeled the opposite as square root 5. We labeled the hypotenuse as 3. And the hypotenuse is always, always, always the diagonal. Okay, then cosine is kk, and that's adjacent over hypotenuse. So the hypotenuse 3 we already labeled, but cosine, remember cosine is kk. So that's why that 2 is the adjacent. Okay, let's see what they were asking for. It says find the other 4 trig functions. Okay, well, let's go. We can either look at the triangle or we can think of reciprocals. I think I'm going to go ahead and do some reciprocals. The reciprocal of sine is CSC. So let's flip that fraction upside down. But then you have to multiply it by the square root, because you can't have that in the bottom. So we get CSC theta equals 3 square root 5 over 5. Now let's do the reciprocal of cosine. I think that's secant theta. So let's flip this 2 over 3. And when I flip that guy, ooh, okay, I didn't have to do a lot of work. It just became 3 over 2. Huzzah! Okay, now we're going to do tangent. And for tangent, you can think of TOA, you can think of y over x, and do the up and down square root 5 over the side-to-side piece 2. I don't really care as long as you do it correctly. Okay, so tangent, you can either think of it as y over x or opposite over adjacent. Either way, let's see what we get. Opposite is square root 5. Huzzah. Adjacent is 2. Hot dog, that's my tangent theta. And you don't have to rewrite that equals tan theta. I'm just doing it because I'm all over the place. Okay, let's do cotangent. Cotangent, you just flip this bad boy. Then you can't have that square root in the bottom. So we get 2 square root of 5 over 5, and that's cotangent. I spelled it wrong. Okay, if you are thinking to yourself, man, Miss Mo, this is a lot of material. It is. So, on your test, on this question, I might not ask for 4 trigonometric functions. I might just say, hey, given all this information, what's the tangent? And you just find one of them. So I did shorten these problems by having you not find every single piece. And like this number 4, it looks like there's a ton of problems on number 4, but I think I only put 3 or 4 of these. Okay. Let's look at number 6. It says, given the following right triangle. Yes. Okay. Right triangle. Don't forget your angle is theta is near the center of the bow tie. Okay. Tangent is opposite over adjacent because it's TOA. Okay. So OPP, yeah, you know me. It's up and down. It's 10. The adjacent is the 11. The hypotenuse, we don't know, but it's the crooked, the diagonal across from the box, the 90 box. Okay, so we didn't have... Now it says cosecant. Oh, no. Okay, let's see what we need for cosecant. Cosecant is sine upside down. Okay, sine is so... Okay, so we need to upside down it. So we need to put the hypotenuse on top of the opposite. Well, we know our opposite is that 10. And for the top, we don't know it. So we're going to have to do that Pythagorean theorem to find the top. Let's go ahead. So first I drew my picture and labeled it. Second, I tried to find what the answer was, but I saw that I need my hypotenuse. So let's go through the Pythagorean theorem. And I think you're going to get 221 equals c squared. And that's not a perfect square. I think you can square root 225, but not 221 perfectly. Okay, let's see if anything can divide into 221. Okay, I could just sit here, or let's try and remember that trick in our calculator. We could say y equals 221 divided by x. I think that's it. Yeah, let's see. Y equals 221 divided by x, and then press graph, and this will tell us all the whole numbers that multiply up to 221, and hopefully one of those is a perfect square. So let's see here. I see 1 times 221. I see 13 times 17. You see that right there? 13 times 17. Okay, so I got 13 times 17, but then let's think. Can you break 13 up? No. Can you break 17 up? No. They're prime. Okay, so which one do I put outside? Neither. You just keep them both in that square root because they're both prime. Okay, so the very last step is to throw that hypotenuse of square root 221 back in the top of our answer for cosecant. Hey, look at that, done with that one. Alright, let's keep going. Number 7. It says, given the following of a right triangle, find sine. Okay, so hopefully if you notice, it's just pretty much the same thing over and over and over. We might be doing SOHCAHTOA on our triangle or on a circle, but it's all the same thing. Okay, the only thing different is sometimes we use negatives and positives. Okay, so first, let's figure out what this hoopla means with the alligators. That means in between pi over 2 and pi. Which quadrant is that? Pi over 2 is at the top, pi is at the left. So our angle is going to be in between pi over 2 and pi. As in, I'm going to draw, a right triangle from the bow tie in this top left quadrant, in between pi over 2 and pi. And remember, that bow tie is, looks like that. Okay, yeah. So since I'm in quadrant 2 in the top left, I need to make it look like this top left triangle. Okay, and theta, or this time, they have the letter Z, but if you want to, you can just put theta. It doesn't matter. Okay, now let's label this cosine. Cosine is kk. Okay, so 4 over 5 definitely has to be the adjacent over the hypotenuse. But the question is, where does the negative go? Well, hypotenuses are always positive. Okay, so that means the negative has to go on the 4. And that makes sense because the adjacent is down below here. And we're saying that the adjacent is -4. And that matches because we had to go left. So that's why it's negative. Okay, so I found which quadrant I was in. I drew the triangle with from the bow tie with the center at the center. I labeled cosine as ka, and then I labeled my picture. Now the question asks for sine z. I'll just put theta because that might panic. us. Okay, and sine is so we need the opposite over the hypotenuse. Well, we know the hypotenuse is 5, but the opposite is, oh no, we're going to have to do the Pythagorean theorem. Okay, when I do the Pythagorean theorem, the hypotenuse is always the c. The hypotenuse is always the c. Always the c. On the last test, a couple of us got that confused. So c is the hypotenuse, or the crooked line across from the 90-degree box. Okay, and then let me fill in the rest of this stuff. With that -4, I have to be careful, because if I don't put parentheses around it, and then put it in the parentheses, and then put it in the calculator. So if I don't put parentheses around that -4 before I square it, I get a -16. But this means -4 multiply -4, so we're supposed to get +16. Well, the only way you can get +16 out of your calculator is if you use parentheses, -4 squared. It's kind of like when you were in college algebra and you were doing that, like the quadratic formula. Remember that when you were doing the quadratic formula in college algebra? Yeah, okay. And this number that you squared, if it was negative and you forgot to put your parentheses, it messed up your whole quadratic formula. So same little theory here. When you square a negative number, be aware that your calculator doesn't know you're squaring the whole thing unless you put parentheses. Okay, keep going. Plus b squared equals 5 squared. Oh my goodness, I think our b just comes out to be some kind of 3. Yeah? Okay, and this is our opposite, and it needs to be positive. And I know it needs to be positive because on my triangle, the opposite piece is this up and down piece, and it's on the positive. You're going up to get there. So the opposite is a positive number. So sine of theta is 3 over the hypotenuse 5. Okay, why don't we check our all students take calculus against that? This is something you might want to include on your cheat sheet. Okay, we are in quadrant 2. Okay, and in quadrant 2, sine is positive because S stands for sine. Remember, A means all of the answers are positive. S means sine and his reciprocal are positive. Yeah, you get the point. Okay, and in this top left quadrant, cosine should be negative, and it is. Okay, so we did the symbols correctly. Let's go to number 8. It says, how far away is the plane from the airport? Okay, this is a horrible picture because you can see that it does not look like the bow tie. But that's okay. Sometimes in real life, triangles are drawn this way, specifically in navigation with airplanes and like boats, cruises. It's this thing called the bearing, which is where you draw your triangle to the up and down axis instead of the side to side. But anyway, you don't care about any of that, and you don't have to know it. The only thing you have to know is sometimes in real life, the triangles are drawn differently because navigation requires us to draw the triangles differently, but we're not there yet. Okay, so it says, how far away is the plane from the airport? Here in the airport, here in the plane. Okay, well, we gotta figure out the hypotenuse. Okay, this is You're probably thinking this is the silliest question I've ever seen, because I got two pieces of a triangle. And I want to find the third piece. Okay, let's do the Pythagorean theorem. That was lame. Okay, the question mark is the hypotenuse. Okay, so we're going to have 152 squared plus 122 squared. It's okay if those are out of order. Who cares? As long as C is the crookedy diagonal across from that 90-degree box. This is going to be big. Okay, let's see here. Okay, I got 37,988. Okay, then let's put a square root on it, because this says we're going to round to the nearest mile. So anytime it says rounding, it means we don't have to keep our answers all pretty and perfect with this square root hoopla. We can just put it in the calculator and get a decimal. Let's go. I got 194.9, so that's maybe 195-ish miles. Yeah. So the question is, how far away is the plane from the airport? 195 miles. Bam! Alright, keep going. Number 9. It says, find the missing pieces, X, Y, and Z only. Okay, this is the second time we've seen this kind of triangle. We have dealt with it in the past when there were more numbers, and it doesn't look like there's a lot of numbers on it this time, but it's okay, we got this. Okay, first, let's find any number that we do have. Oh, 400, hey! Okay, and that is what piece of this left triangle? So on this left triangle, there's technically a 90-degree angle, because if you have a 90-degree angle on one side of a straight up and down line, you have to have it on the left side also. Okay, so now that I got that 90 drawn, I know that this 400 is the hypotenuse. Okay. Well, if I'm looking at this 30 degrees, I know that H is the opposite of this 30 degrees. Yeah. Okay, well, let's try and find that opposite piece. Okay, what do we know that has H and O in it from SOHCAHTOA? Because we're dealing with triangles. I see a triangle. So we're going to say sine 30 degrees equals the opposite, X, which we don't know, over the hypotenuse, 400. And then we're going to get X by itself. Okay, how do we get X by itself? Well, whatever we're dividing by, we're going to multiply it. And we're going to get 400 sine 30 degrees equals X. And then let's keep going. We get 400 sine 30. Oh, and make sure you are in degrees. Okay, awkward. I got X is 200. How nice is that? Okay. Okay, eventually we're going to have to find the bottom of this triangle, so let's go ahead and whip out the Pythagorean theorem now that we have that 200. So I'm going to say a squared plus b squared equals c squared. 200 squared plus b squared equals 400 squared. And you might have had that 200 in the spot of the b. That's totally okay. Okay, so I think I get 120,000. What in the world? Okay, now if I square root that, we can round to the nearest whole number. So I think I got 346. So 346 is the bottom piece of this triangle. It's not the letter Z yet, but we're going to get there. Okay, now let's look at this triangle over here on the right. Okay, we're going to do the same thing. I got 60 degrees. That y is the hypotenuse. That 200 we just found is still the opposite. So let's use sine. Only this time we're going to have sine of 60 degrees. Equals the opposite, we know, 200. Over the hypotenuse, we don't know why. Okay, this is where on the last test, a lot of us pooped out. Okay, we cannot have that y in the bottom, so you got to multiply by the by the y. And we get y sine 60 equals 200. Then divide by sine 60. It's an extra step. This is what some of us missed on that last test. Okay, so I get 231-ish. Okay, good. But we need that bottom piece of the triangle so that we can find the total bottom piece of the huge triangle. So let's find the adjacent. So we're going to do a squared plus b squared equals c squared of this triangle on the right. And I think it rounds to 116 maybe. Yeah. Okay, so the question was, what is x? Well, we already found the x was 200. It also asked for the y. We just found that. It was 231. And then the z is along the bottom. So it should be the whole bottom, that 346, plus what we just found is the adjacent of this triangle, which is this 116. And that gives us 462. So these are our x, y's, and z's. Okay, this is not the whole video for the test review, but it can start